Hello everyone, good evening. So here we shall solve some more JEE Mains previous year questions on the chapter laws of motion. So any doubts if you have in any steps, then please write that in the comments section. We shall obviously clarify them in the subsequent videos, and also in any other chapter of physics. If you have more difficulty, then please mention the name of that chapter also in the comment section, so that we can give more priority on it and solve more and more questions on that chapter. So here it is told that the position vector of a particle related to time t is given by r vector equals to 10 t I cap plus 15 t squared j cap plus 7 k cap meter. The direction of net force experienced by the particle is direction of net force. So net force is mass into acceleration. So acceleration is dv by dt, and which can also be written as d square r by dt square. Hence why v is dv by dr by dt. So first we have to find v, which is dr by dt. That will be d by dt of 10 t I cap plus 15 t square j cap plus 7 k cap meter per second. So this will be 10 I cap plus 215 so 30 t j cap, this much meter per second. Then acceleration will be dv by dt. So this will be 30 j cap meter per second. So therefore the net force is acting, that is equal to 30 m, 30 into the mass m, this much into j cap Newton. So it means the net force is acting along the positive y-axis. So option B is the correct answer. Then it is told three forces F1 10 Newton, F2 8 Newton, F3 6 Newton are acting on a particle of mass 5 kg. The forces F2 and F3 are applied perpendicularly so that the particle remains at rest. If the force F1 is removed, then the acceleration of the particle is so F2 and F3, their resultant will, if they are kept at right angles, they are kept perpendicularly, then their resultant will be square root of 8 square plus 6 square, that is equal to 10 Newton. 10 Newton, and it should act opposite to F1. So if the force F1 is removed, then the net force acting on it will be 10 Newton only, and then the acceleration will be force by mass. Mass is 5 kg, so that is 2 meter per second square. So option C is the correct answer. And here it is told at any instant the velocity of a particle of mass 500 gram is velocity, that is 2t I cap plus 3t square j cap meter per second, with the force acting on the particle at t equal to 1 second. Force acting on the particle, that is equal to I cap plus x j cap Newton. At t equal to 1 second it is acting, then the value of x will be velocity, and the mass is 500 gram, mass is 0.5 kg. Force acting is this. Okay, so it means the force is equal to mass into acceleration. So now acceleration will be dv by dt. So it is told the force that is acting, so it is the force at t equal to 1 second. Okay, Here the acceleration will depend on time also. Acceleration is not constant. So acceleration will be d by dt of v, that is 2t I cap plus 3t square j cap meter per second square. So this will be equal to 2 plus 2 I cap plus 6t j cap meter per second square. Acceleration will be this. The force is mass into acceleration. That will be m into, so that is 2m I cap plus 6t into m j cap, this much Newton, and this is equal to I cap plus x j cap. Then x we have to find out. So now therefore it means that 2m equals to 1, means m is half. The mass of that particle is half kg. Of obviously it is 0.5 kg only. Then at t equal to 1 second, that will be I cap plus 6m, 6 into m, 6 is 30, that is 3 j cap. So it means x will be equal to 3. Option D is the correct answer. Here it is told that, as shown in the figure, a block of mass 10 kg lying on a horizontal surface. Its mass is 10 kg. It's pulled by a force acting at an angle of 30 degree with the horizontal. So this is the horizontal. For mu s is acting, mu s is 0.25. The block will just start to move for the value of f. The block will just start to move for the value of f. So the block will just start to move, it has been told. So this way it will be f sine 30. This is f cos 30. And normal reaction also will act. And this is mg. G is 10. So therefore n plus f sine theta, f sine 30 degree, that is equal to mg. So n will be equal to mg, that is 10 into 10, that is 100 minus f sine 30, means f by 2. N is this. And the frictional force is this. So it just starts to move. So it means f cos 30, that should be equal to the frictional force, that is mu s into n. Therefore f cos 30, that is f root 3 by 2, that is equal to mu s, that is 0.25, which is 1 by 4. 1 by 4 into 100 minus f by 2. So this will be 2 2s of 4. So f will be equal to 1 by 2 root 3 in, okay, or I can say this is root 3f, that is equal to 50 minus f by 4, means f into root 3 plus 1 by 4, that is equal to 50. So therefore f will be equal to 50 divided by, this is 0.25 plus 1.732. So this will be approximately 50 by 1.98. 1.98 means 2 only approx. So it is approximately 25. 25.2 I can say. So option A is the correct answer. Then here it is told figures A, B, C, and D show variation of force with time. Figures A, B, C, and D show variation of force with time. The impulse is highest in which figure? That has been told. So impulse that is equal to the integral f dt. It means it is the area under force time graph. Area under force time graph. So that will be equal to here the area in the first case, the impulse in part A, impulse IA, that is equal to half into base. Base is 1 second to height. Height is 0.5. That is 0.25 uh, Newton second. And impulse in part B, that is the area under this graph in figure B. So that is length into breadth. Length is 2 seconds and breadth is 0.5 Newton. So this is 1 Newton second. Then impulse in part C, that is half into base. Base length is 1 second and height, that is 0.75 Newton second. So now 0.75, it means 3 by 4. So this is 3 by 8 Newton second. So this is approximately 8. 3 8s are 24. 3 8s are 24. Then 60. 7 is 56. 5 8s are 40. Okay. So 0.375 Newton second. An impulse in part D, that will be equal to half into base. Base is 2 second to height. Height is 0.5 this much Newton second, which is 0.5 Newton second. So obviously in part B, the impulse is the highest in figure B. So option D is the correct answer. A block of mass 5 kg is placed at rest on a table of rough surface. A block of mass 5 kg is placed at rest on a table. This is a table of rough surface. Now if a force of 30 Newton is applied in the direction parallel to the surface of the table, the block slides through a distance of 50 meter in a time interval of 10 seconds. Then the uh, uh, displacement is 50 meter in time interval 10 seconds. So then the coefficient of kinetic friction is the coefficient of kinetic friction mu k that we have to find out. So 30 Newton force is applied. If this is the applied force and this is the frictional force, so the frictional force that is equal to the kinetic friction, which is mu k into n. And here normal reaction will be same as mg only. mu k into normal reaction, and normal reaction will be equal to mg. So therefore Fk, that will be mu k into mg, which is the frictional force. And then so the net force will be applied force minus the frictional force, and that is equal to mass into acceleration. Block slides through a distance of 50 meter in a time interval of 10 seconds. So then we can say that suppose the block starts from rest only. So then S will be equal to half a t square, half into a into t square. So S is 50 meter and t is 10 seconds. T is 10 seconds. So therefore I can say 50, that is equal to half into a into 10 square. So therefore a will be equal to 100 by 100. So that is 1 meter per second square. So the acceleration is 1 meter per second square. Acceleration is 1 meter per second square. So then therefore the net force, that is 5 Newton, that is equal to friction, the applied force, that is 30 minus the friction. So therefore the frictional force, that is 30 minus 5, that is 25 Newton, and that is equal to mu k times mg. M is 5 and g is 10. So therefore mu k, that will be equal to 25 by 50, that is equal to half. 1 by 2, that is 0.5. Yeah, 0.50 is the coefficient of kinetic friction. So option D is the correct answer. And here it is told body of mass 10 kg is moving with an initial speed u of 20 meter per second. Its mass is 10 kg. The body stops after 5 seconds due to friction in between the body and the floor. Yeah. So the body stops after 5 seconds. At t equal to 5 seconds, the final velocity will be 0. Friction is there, friction is acting. The value of the coefficient of friction is mu k into mg. This mu k has been asked. Acceleration due to gravity is 10 meter per second square. So here the retardation A will be equal to frictional force by mass, that is equal to mu k into g. So that will be mu k into 10, or I can say 10 mu that we have. So this mu has been asked, we have to find out. So we can say that v equal to u plus 80. So therefore d is 0 equal to u, that is 20 minus 10 mu into t is 5. Since y, this is the retardation which is caused by the frictional force. Now this is 50 mu, that is equal to 20, so therefore mu will be equal to 2 by 5, so which is 0.4. So 0.4 is the value of the coefficient of friction. So option D is the correct answer. And here it is told, as shown in the figure, a 70 kg garden roller is pushed with a force of F equal to 200 Newton at an angle of 30° with the horizontal. At an angle of 30° with the horizontal. "70 kg garden roller is pushed with a force F, which is equal to 200 Newton at an angle of 30° with the horizontal. The normal reaction of the roller is..." An angle of 30° with the horizontal. The normal reaction on the roller is... The normal reaction of the roller is... So its weight is 70 kg, its mass is 70 kg, so mg will act downwards, and F equal to 200 Newton at an angle of 30 degree, the horizontal, the normal reaction. Okay, so like this, the force component along the horizontal, that will be, this will be 30 degrees, so it will be F cos 30, and this way it will be F sin 30. So therefore the normal reaction, that will be equal to F sin 30 plus mg. So F sin 30, F is 200 into half plus mg means 70 into 10, that is 700 plus 100, that is 800 Newton. So option A is the correct answer. Then it is told a block of root 3 kg is attached to a string whose other end is attached to the wall. Block of 3 kg is attached to a string. Block of root 3 kg, it is attached to a string whose other end is attached to the wall. An unknown force F is applied so that the string makes an angle of 30 degree with the wall. The tension T is given. Tension T is how much, that we have to find out. So this will be tension T. Now this is here mg is acting, mg. This is F. Now this is 30 degree. So this is T cos 30 degree. This is T sin 30 degree. T sin 30. So therefore I can say T cos 30 degree, that is equal to mg. So therefore T will be equal to mg by cos 30. Mg, that is root 3 into g, that is 10 by cos 30, that is root 3 by 2. 2 will go up. So that is 20 Newton. T is 20 Newton. So option D is the correct answer. Then it is told a force acts for 20 seconds on a body of mass 20 kg starting from rest. So it starts from rest, u is equal to 0, after which the force ceases. A force will act, after which the force ceases, of mass 20 kg starts from rest. So the force is acting for from t equal to 0 to t equal to 20 seconds only. And then body describes 50 meter in the next 10 seconds, the value of the forces. So from t equal to 0 to t equal to 20 seconds, the force is acting, and then from t equal to 20 to t equal to 30 seconds, in this time, it is moving 50 meters. Then how much is the force that is asked? So now, here it will gain some velocity. Let's call it V1. Okay. So here we can apply, here the force is not acting. So here it is moving with a constant velocity V only. So this V you have to find. So then we can say that V, this 50s, that is equal to Vt, V into T. T is 10 seconds. So V will be 5 meter per second. So V is 5. So V equal to U plus 80. So therefore V, that is 5. 5 is equal to 0 plus A into T. T is 20. So acceleration is 5 by 20. That is 5 4s are 20. That is 1 by 4 meter per second square. Now, therefore, the force that will be equal to mass into acceleration. Mass is 20, 20 into 1 by 4, that is 5 Newton. So 5 Newton is the force which is acting on the object. Option C is the correct answer. Then here it is told the time taken by an object to slide down 45-degree rough inclined plane, 45-degree rough inclined plane is n times as it takes to slide down a perfectly smooth. So here, yeah, suppose it is a smooth inclined plane, then suppose it takes time t seconds to move down the inclined plane. Let's say this length is L, and the coefficient of, and if it is a rough inclined plane, rough, then if the same length it will cover, same length L it will cover in n t seconds. Here it will cover in t seconds if it is rough. And the coefficient of kinetic friction between the object and the inclined plane is, this mu has been asked. So here how much time it will take? Here actually mg is acting, mg of the on the object, mg is acting on the object. So, and here mg, this is theta, then this will be 45 degree also. So this is mg cos 45, mg by root 2. Here also this will be mg sine 45, that is mg by root 2. So therefore L, I can say it starts from rest only. It starts from rest here, u equal to 0. Here also it will start from rest only. So L equal to half at square. Here acceleration will be the net force downwards by mass, that is g by root 2. So half 8 into t square. And in the second case, L will be equal to half into acceleration. Here acceleration will be mg by root 2. This is the downward force, and the upward force of the incline, that is the kinetic friction, that is mu into n. N is mu mg by root 2. So this will be g by root 2 minus mu g by root 2. The net force by mass. So this is the acceleration in the second case. I can call it as a dash. So it is half into a dash into t nt square. So that is half into g by root 2 into 1 minus mu. This is g by root 2 into 1 minus mu, half into a into nt square, n square t square. So then mu is how much, that we have to find out in terms of n. So therefore I can say half g by root 2 into t square, that is equal to, so this is also the same length, this is also the same length, L and L. So I can say half into g by root 2 into t square, that is equal to half into g by root 2, g by root 2 into t square into 1 minus mu into n square. So these two will get cancelled. So 1 minus mu into n square, that is equal to 1. So I can say 1 minus mu is 1 by n square. So mu will be equal to 1 minus 1 by n square. So option A is the correct answer. Okay, so here it is told that a block of mass m slides down the plane. Block of mass m slides down the plane. Mass is m, slides down this plane, and it is inclined at an angle of 30 degree, and it slides down with an acceleration g by 4. Then the value of the coefficient of kinetic friction, mu, that is how much? So mu k has been asked. Mu k is the coefficient of kinetic friction. So now mg is acting vertically downwards, and this way this will be mg cos 30. This will be 30 degree, g cos 30, and this way will be mg sin 30. And this will be the normal reaction, and this way friction will act. The friction that will be equal to mu k into n, since here kinetic friction only will act. and n will be equal to mg cos 30. That is equal to mg into root 3 by 2. So this will be equal to mu k into mg into root 3 by 2. And the downward acceleration, that is mass into acceleration, that is equal to the net force downward, that is mg sine 30 degree, mg sine 30 minus friction. So therefore I can say ma, that is equal to mg by 2 minus mu k mg into root 3 by 2. So m mass will cancel out, and acceleration has been told that is g by 4. So it means that g by 2 minus g into root 3 mu k by 2, that is equal to g by 4. So g also we can cancel out. Then we will get 1 by 2 minus root 3 by 2 mu k. 1 by 2 minus root 3 by 2 mu k, that is equal to 1 by 4. So therefore mu k into root 3 by 2, that will be equal to 1 by 2 minus 1 by 4, that is 1 by 4 only. So mu k will be equal to 2 by root 3 into 1 by 4. So this is 2 to the 4. So mu k equals to 1 by 2 root 3. So therefore the value of the coefficient of kinetic friction is 1 by 2 root 3. So option C is the correct answer. Then here it is told, consider a block kept on an inclined plane, inclined at an angle of 45 degree as shown in the figure. If the force required to push it up the incline is 2 times the force required to just prevent it from sliding down, force required to push it up the incline is 2 times the force required to just prevent it from sliding down. The coefficient of friction between the block and the inclined plane mu is equal to. So here mg is acting downwards, so mg cos theta, that is acting normal to the incline. Here theta equals to 45 degrees, and this is mg sine theta, at theta is 45 degrees. Here frictional force is acting, which is equal to mu into n, and normal reaction is also acting up, acting perpendicular to the inclined plane. So therefore n will be equal to mg cos theta. So therefore frictional force, that will be equal to mu into mg cos theta. So now here it is told that how much, let's say F1 is the force required to just prevent it from sliding downwards. So F1 plus friction, that will be equal to mg sin theta. So F1, that will be equal to mg sine 45, that is 1 by root 2, minus friction is mu mg by root 2, since cos 45 is also root 2. Cos 45 is also 1 by root 2. So this is mg by root 2 minus mu mg by root 2. The force required to push it up the incline. So if it is pushed up the incline, then the friction will act downwards. Then F2 will act. F2 will act upwards. Then we will say F2 will be equal to friction, that is mu into n plus mg sin theta. So this will be mu mg by root 2 plus mg by root 2. So this f2 is 2 times of f1. F f2, that is mu mg by root 2 plus mg by root 2, that is equal to 2 times of mg by root 2 plus minus mu mg by root 2. So from here we have to find out value of mu. So mg by root 2 I can take as common and I can cancel them. So then we will get mu plus 1, that is equal to 2 into 1 minus mu. So therefore I can say it will be 1 plus mu, that is equal to 2 minus 2 mu. So therefore this will be 3 mu, that is equal to 2 minus 1, that is 1. So therefore mu will be equal to 1 by 3. 1 by 3, it means it is approximately 0.33. So option B is the correct answer. Then here it is told an object of mass 8 kg is hanging from one end of a uniform rod CD of mass 2 kg. It is of mass 2 kg and length is 1 meters. 1 meter is the length, mass is 2 kg. It is pivoted at end C on a vertical wall as shown. It is supported by a cable AB such that the system is in equilibrium. The tension in the cable is. So you have to find how much is the tension in this cable. So now here we can apply rotational equilibrium about the point C. So the net torque about point C, that is 0. That's why it is in equilibrium. So I can say now the center of mass of the rod is at the midpoint, which is at 50 centimeter from the point C. So this is the mass is 2 kg. So 20 Newton force is acting here at 50 centimeter. And this T is acting at an angle of 30 degree and and 8 kg 8 kg object is hanging from the end D. So it means here 80 Newton is acting. Since here it is told G, we have to take it as 10 meter per second. So now torque about point C is 0. So now if we tell that the sum of the anti-clockwise torque equal to sum of the clockwise torques. So therefore the torque of the tension force at the point B, that is torque of the tension force at point B, torque of the tension force, that is anti-clockwise torque, and that is equal to the torque of the mass of the rod, the center of mass of the rod, um, or you can say the torque of the weight of the rod, the torque of the weight of the rod plus the torque of the 8 kg object, the torque of the 8 kg object. So now the torque of the tension force, that will be equal to R cross F now. This T we can take component. This will be T sine 30. This will be T cos 30. So now T cos 30 will have no net torque about point C. So now therefore the torque of the tension, that is T sine 30, that is T by 2 into this length, that is 60. Here it is saying this length is 60 centimeter. So it means the length of the rod is not 1 meter, it is 60 centimeter, 40 centimeter. Okay, 60 plus 40. Okay. So it means the point B is at 60 centimeter, and the from point B to D, this length is 40 centimeter. And here the weight is not acting. The weight of the rod is acting as it's at its center of mass only. Torque, okay. The weight will be 20 Newton. And here we have 80 Newton. So this is at 60 centimeter. So therefore this will be T sine 30 T by 2 into 60 centimeter, or I can say 0.6 meter, since torque is R cross F and equal to the clockwise torque. It means that the torque of the weight, that is 20 Newton into the this length, that is 50 centimeter or 0.5 I can tell, plus R cross F, and plus the torque of the 80 Newton force, which is 80 into this is 1 meter. So then the tension we can find out. So this will be T into 0.3. So it is T into 0.3, that is equal to 10 plus 80, that is equal to 90 by 0.3. This will be T will be equal to 900 by 3, so that is 300. So the tension is 300. So option D is the correct answer. Then here it is told, as per given figure, a weightless pulley P is attached on a double inclined frictionless surfaces. Then here it is told as per given figure, a weightless pulley P is attached on a double inclined frictionless surfaces. The tension in the string will be a weightless pulley P is attached on a double inclined frictionless surfaces. So since the string is massless, so same tension will act. So here there is this is tension force, and this pulley is fixed. The pulley is fixed. So here G is 10, so 40 Newton is acting here. Here 10 Newton is acting downwards. So here 10 sine 30 will act down the incline, and here 10 cos 30 will act. And here also this will be 40 cos 60. This will be 40 sine 60. Sine 60. Now here also this will be tension force. This will be also tension, and these surfaces are frictionless. So suppose we assume that the system is moving downwards with an acceleration a. So this 1 kg object will move upwards with the same acceleration a. Since they are connected by a string, so the motion is constrained. So if 4 kg moves downwards with acceleration a, 1 kg also will move upwards with acceleration a. Now here we can say that this will be 40 sine 60. It means 40 root 3 by 2 minus t, that is equal to 4 into a, mass into acceleration, and then t minus 10 sine 30, 10 by 2, that is equal to 1 into a. So therefore if we add them, then we will get 20, this is 5. So this will be 20 root 3 minus 5, that is equal to 4a plus a, that is equal to 5a. So a will be equal to 4 root 3 minus 1. So acceleration is 4 root 3 minus 1, but here the tension has been asked. So t will be equal to 5 plus a. From here we can get t equal to 5 plus a. So t will be equal to 5 plus 4 root 3 minus 1. So 5 minus 1 is 4. So it is 4 root 3 plus 4. So you can say this will be 4 into root 3 plus 1 Newton. So option D is the correct answer. Then here it is told that an statement 1 is an elevator can go up or down with uniform speed when its weight is balanced with the tension of its cable. The elevator can go up or down with uniform speed when its weight is balanced with the tension of its cable. That will be true only, since why an elevator, if it goes up, then the rope has got a tension T, and the tension in the cable, that is T, and the weight of the lift, that is mg. So if T equal to mg, then only it will move up or down with an uniform speed. Since by uniform speed, it means that the net force acting is 0. And here it is told in the statement 2 that force exerted by the floor of an elevator on the foot of a person standing on it Force exerted by the floor of an elevator on the foot of a person standing on it is more than his or her weight when the elevator goes down with increasing speed. Force exerted by the floor of an elevator on the foot of a person. So it is the normal reaction which is acting upwards on the person standing on it is more than his or her weight when the elevator goes down with uniform speed. So it is, so if it is going down with uniform speed, it means acceleration is zero only. Then the normal reaction will be equal to his or her own weight. So hence, statement 2 is false. Statement 2 is false, but statement 1 is true. Statement 1 is true and statement 2 is false. So option D is the correct answer. Then here it is told two bodies of masses m1 equal to 5 kg and m2 equal to 3 kg are connected by a light string going over a smooth light pulley, going over a smooth light pulley connected by a light string over going over a smooth light pulley. They are connected by a light string going over a smooth light pulley on a smooth inclined plane as shown in the figure. The system is at rest. The force exerted by the inclined plane on the body of mass m1 will be. So the inclined plane is smooth. Smooth means there is no friction. Okay, so force exerted by the inclined plane on the body of mass m1 will be only the normal reaction n. So that we have to find out. Mm, the system is at rest, it is told. System is at rest. So it means this is m1g is the weight. So this way, this will be angle theta. This will be m1g cos theta. And this way it will be m1g sin theta. This will be the tension force. This will be also the tension force. And this is m2g. The system is at rest means acceleration is zero in the system. So then you can say t equal to m2g and t also equal to m1g sin theta. So therefore I can say m2g that will be equal to m1g sin theta. So g will cancel out. So sin theta will be equal to m2 by m1, which is equal to m2 is 3, m1 is 5. So sin theta is 3 by 5. The force exerted by the inclined plane on the body of mass m1 will be. So that is n m1g cos theta that we have to find out. So m1 that is 5 kg into g is 10 into cos theta. So sin theta is 3 by 5. So cos theta will be root over 1 minus sin square theta. So 1 minus 9 by 25, which is equal to square root of 25 minus 9, that is 16 by 25. So therefore cos theta will be equal to 4 by 5. So this into 4 by 5 will cancel out. So that is equal to 40. So it means option, so 40 Newton is the force exerted by the inclined plane on the body of mass m1. So option B is the correct answer. Then here it is told a uniform metal chain of mass m and length L passes over a massless and frictionless pulley. A uniform metal chain of mass m and length L, it passes over a massless and frictionless pulley. It is released from rest with a part of its length L is hanging on one side and rest of the length L minus L is hanging on the other side of the pulley. At a certain point of time when L small is equal to L by x, the acceleration of the chain that is equal to g by 2, then the value of x is. So here the acceleration of the chain, it means if this part goes downwards with acceleration a, then this will go, the left part will go upwards with acceleration small a. So therefore I can say, and mass per unit length mu, that is constant since it is a uniform chain. So mass per unit length m by L I can take, m by L, that is the mass per unit length of the chain, which is constant. The chain which is constant since it is a uniform chain. So therefore mass of the part on the right, that is let's say m1, mass of the part on the left, that is m2. So m1 will be equal to L minus small l into mu, and m2 that will be L into mu. So now therefore we can say that m1g acceleration, the weight is acting downwards m1g, and here also the weight is acting downwards m2g. So we can say m1g minus m2g, m1g minus m2g, that is equal to mass of the entire chain, mass into acceleration. Therefore acceleration, that will be equal to m1 minus m2 into g by m, and that is given as equal to g by 2. Then x you have to find out, if here L is given as L by x. So therefore acceleration, that is equal to m1, that is equal to, and m also I can write equal to mu into L. So m1 is mu into L minus L, minus m2 is mu into L. So this part into g divided by, this is mu into capital L, that is equal to g by 2. So g and g will get cancelled, and we'll say mu L minus mu L minus mu L divided by mu into capital L. So that is equal to 1 by 2. So mu I can take as common and I can cancel out. So this will be L minus 2L by L, that is equal to half. So now L minus 2 into small l is L capital L by x by L, that is equal to half. So I can take L as common and I can cancel. So this is 1 minus 2 by x that is equal to half. So therefore 2 by x, that is equal to 1 minus half, that is half. So x will be equal to 4. So x will be equal to 4. Option D is the correct answer. And here it is told a block of mass m slides down a rough inclined plane with constant velocity. It slides down with a yeah. A block of mass m slides down a rough inclined plane. So here, let's say the coefficient of friction is mu. So it moves downwards with a constant velocity. V is constant, so acceleration will be zero only. Uh, the angle made by the inclined plane with the horizontal is theta. Then the magnitude of the contact force will be. So the contact force is actually the vector sum of the normal reaction force and the frictional force. So therefore, the net contact force, if you want to find, the net contact force, so that is equal to the resultant of frictional force and the normal reaction force. So it will be square root of Fr square frictional force square plus normal reaction square. So here its mass is m. So here mg is acting vertically downwards and this angle is theta. So this will be mg cos theta and this will be mg sin theta. Okay. The sin theta. So now acceleration is zero only. So it means upward force, which is frictional force, that is equal and it is moving with a constant velocity only. So it means here kinetic friction is acting. Fk, kinetic friction is acting. So the friction will be mu times n, and frictional force that is equal to mg sin theta. It will be equal to mu times mg cos theta. And also the normal reaction will be mg cos theta only. So therefore the net contact force, that is equal to square root of mg sin theta whole square plus mg cos theta whole square. So this will be equal to mg, I can take common outside, and it will be sin square theta plus root over sin square theta plus cos square theta, that is 1. So therefore the net contact force is equal to mg only. So option A is the correct answer. Then here it is told a block A takes 2 seconds to slide down a frictionless incline of 30 degrees. Its angle of inclination is 30 degrees and length L. So the block will take, so it will start from point A at the top till the bottom of the incline. It will start from the top of the incline to the bottom of the incline. It takes 2 seconds. The time taken by it to reach from the top to the bottom of the incline, that is 2 seconds, and it is of having length L. It is having length L. It is kept inside a lift. Right down a frictionless incline and length L is kept inside a lift going up with uniform velocity. So it is kept in a lift which is going up with a constant velocity. So if velocity is constant, it means acceleration is zero for the lift. If the incline is changed to 45 degrees, the time taken by the block to slide down the incline will be approximately. Acceleration is zero, it means there is no pseudo force. So G is only then the acceleration acting, which is downwards. So this is frictionless, so it is smooth surface. So here we have initial velocity, that is okay. So it starts from rest here, and here mg sine 30, that is mg by 2 is acting vertically. Mg by 2 is acting down the incline. Mg sine 30. So mg by 2 is mass into acceleration, which is acting down the incline. So therefore acceleration is g by 2. So therefore the time required is 2 seconds. So I can say s, that is L equal to ut. U initial speed is 0 only, since it will start from rest. So L equal to half g by 2 half at square. Time required is 2 seconds, so 2 square. So this will be g by 4. So it is equal to g. So the length L is equal to g. The length of the incline L, that is equal to g. Now, if the angle is made 45 degrees, then therefore the acceleration will be equal to g cos g sine 45 degrees, which is equal to g by root 2. So now, therefore, the new value of acceleration a dash, that is equal to g by root 2 a dash, I can say g by root 2. So therefore, L will be equal to half a dash into t dash square. The new time interval we have to find out. So L equal to g, and it half into a dash is g by root 2 into t dash square. So g and g will cancel. So therefore t dash square, that is coming equal to 2 root 2. T dash square, that is coming equal to 2 root 2, which is equal to 2 into 1.414, that is 2.828. So therefore t dash will be equal to square root of 2.828, which is approximately 15 square is 225, 16 square is 96, 16, 25, 256, and 17 square is 289. So it will be approximately 1.7 seconds. So it means the closest answer is option C, which is 1.68 seconds. So the time taken for the block to slide down the incline, it will be 1.68 seconds. And here it is told a bag is gently dropped on a conveyor belt moving with a speed of 2 meter per second. A bag is gently dropped on a conveyor belt. Bag is dropped, and which is moving with a constant speed of 2 meter per second. The coefficient of friction between the conveyor belt and the bag mu, that is 0.4. Initially, the bag slips on the belt before it stops due to friction. The distance traveled by the bag on the belt during slipping motion is. So initially the bag is moving with a speed of 2 meter per second relative to the conveyor belt. So after some time it starts to move along with the conveyor belt. So therefore the friction is causing the retardation here. Friction is causing the retardation. Now the frictional force that will be equal to the kinetic friction, which is mu mg. Mg is the weight. Normal reaction is also mg only, so it will be mu mg. So therefore mu mg, that is equal to ma, that is mass into acceleration. So therefore the retardation is mu into g. Retardation is mu times g. So therefore the distance traveled s, that will be equal to half. Okay, it is, you can say v square equal to u square plus 2s. S we have to find out. So the final relative velocity of the bag relative to the belt, that is 0 only. So v is here, v is the velocity of the bag. So it is the final velocity of the bag relative to the belt. Relative to the belt. And u is what? That is, u is the initial velocity of the bag relative to the belt. Okay. So v is 0, 0 square equal to u square. U is 2, 2 square minus 2 into mu g into s. S we have to find out. G is 10, so frictional coefficient is 0.4, 0.4 into 10, that is 4 meter per second square. So this is the value of mu g. So therefore you can say 4 equals to 2 into 4 into s. 4 will cancel out, so therefore s will be equal to 1 by 2 meters. So the distance traveled by the bag on the belt during slipping motion, that will be 0.5 meters. So option B is the correct answer. So then here it is told two masses m1 and m2 are tied together at the two ends of a light inextensible string that passes over a frictionless pulley. When the mass m2 is twice m2, here it is told case 1. Case 1 is that so the strings are light and inextensible and the pulley is also frictionless. So if it is told if m2 is twice of m1, then the acceleration of the system, is a1, and if m2 equal to thrice of m1, if m2 is 3 times m1, then the acceleration of the system is a2. Then we have to find out a1 by a2 value we have to find out. So therefore we can say m2 here, obviously in both the cases m2 is more than m1. M2 is more than M1, so the system will accelerate downwards on the right side, and it will accelerate upwards on the left side, and having the same acceleration. We can say here M2G will act, M2G, and here towards M1G. So therefore here we can say M2G minus m1g, that will be equal to m1 plus m2 into a. So then acceleration, that will be equal to m2 minus m1 into g by m1 plus m2. So therefore in case 1, the first case, when m2 is twice of m1, then we can say that acceleration a1, that will be equal to, that is 2m1 minus m1, that is m1 g by m1 plus 2m1, that is 3m1. So that will be equal to g by 3. So a1 is g by 3 meter per second square. Okay, and then therefore similarly in case 2, that is a2, the acceleration is a2. So here m2 is 3m1, so 3m1 minus m1, that is 2m1 by 3m1 plus m1, that is 4m1 into g. So that will be equal to g by 2. So a1 is g by 3, a2 is g by 2. So therefore a1 by a2, that we have to find out. So a1 is g by 3, a2 is g by 2. So it will be 2 by 3. 2 by 3, so option B is the correct answer. Yeah, so here it is told that three masses M, M1 and M2 are arranged in a system as shown in the figure. All the surfaces are frictionless and strings are inextensible and weightless. The pulleys are also weightless and frictionless. A force F is applied on the system so that the mass M2 moves upward. Mass M2 moves upward with an acceleration 2 meters per second square. Value of F is. So if we draw the free body diagram of the mass M, then on it two tension forces are acting, T and P, like this, and then normal reaction is acting downwards, which is equal to M1G, and here force is acting F, and Mg is acting. Then for the mass M1, the tension force is acting, and one pseudo force is acting, M1 into A. Since the system, suppose it will go forwards with an acceleration A, so now for M2, M2G is acting vertically downwards and tension force is acting upwards, and it is going upwards with an acceleration A. It is 2 meter per second square. It means that M1 will also will move towards the left. In acceleration 2 meter per second square. Then And this mass will also move forward by an acceleration a. Then we can say F minus T, that is equal to M into A. Here pseudo force is also acting, which is M2 into A. Here some normal reaction will also act, which is normal reaction N2. Suppose this will be N2. I can say F minus T minus N2, that is equal to MA. N2 will be equal to M2 into A. And from here we can say that T, okay, M1A minus T is equal to M1 into 2. And here also T minus M2G, that is equal to M2 into 2. So now if we add them, then T will get cancelled. Then we will get M1A minus M2G, that is equal to M1 plus M2 into 2. From here acceleration we can find. So 10A minus M2 is 20. 20 into G, that is 10. 200, that is equal to M1 plus M2, that is 30. 30 into 2, that is 60. So 10 we can take common and cancel, and so A will be equal to 26 meter per second square. Equal to 26. Then you can find out T also. T will be equal to M2G. M2, that is 20. 20 into 10 plus M2. M2 into 2. Into 2, that is 40. T equals to 240 Newton. And N2, that will be equal to M2 into 8, is 20 into 26. N2, that will be equal to M2 into 8. N2, that is 20. 20 into acceleration, that is 26, is 520. N2 equal to 520. So F minus T minus N2, that is equal to MA. Therefore, F will be equal to T plus N2 plus MA. So T will be equal to 240, 140 plus N2 into that will be 520 plus m into a equals to 100 into a. A is 26. Therefore, this will be 240 plus 520 plus 2600. So 2600 plus this will be 760. So this will be 0.63360. 3360 Newton. So option A is the correct answer. A is the correct answer. And here it is told monkey of mass 50 kg climbs on a rope. Monkey of mass 50 kg climbs on a rope which can withstand a tension of 350 Newton. If the monkey initially climbs down with an acceleration 4 meter per second square and then climbs up with an acceleration 5 meter per second square, then choose the correct option. So then tension force you have to find out. So when in case 1, when the monkey is climbing down, then what is happening? So tension force is acting upwards. Force on the monkey, which is the reaction of the tension that is acting upwards, and 50 into G, so 500 Newton is acting downwards. So I can say 500 minus T, that is equal to M 50 into A, it is 4. So tension will be equal to 500 minus 200, that is 300 Newton. And the case 2 is that the tension force is acting upwards and 500 Newton is acting downwards. Then so T minus 500, that is equal to can withstand the tension of 350 Newton. So T minus 500, that will be equal to M into A. M 50 into A. A is 5 in the second case. So therefore T will be equal to 250 plus 500, that is 750 Newton. So while going up, the tension that is required, that is 750 Newton, but here it is told the rope can withstand the tension of 350 Newton only. So in the first case, the tension is less than 350, so it will not break. But in the second case, the rope will break. The rope will break. Since why 750 Newton is more than the amount of tension which the rope can withstand. So the rope will break while climbing upward, C option, and T equal to 300 Newton while going downward. So option C is the only correct answer. Then it is told that for a free body diagram shown in the figure, the 4 forces are applied in the X and Y directions. Then what additional force must be applied at what angle with positive x-axis so that the net acceleration of the body is 0. So the net force towards the net force acting, that is equal to here in this case, that is uh, minus I cap and minus j cap. Since why 1 Newton net force is acting downwards and 1 Newton net force is acting towards the left. So therefore it is root 2 into minus I cap minus j cap by root 2. It is acting at an angle of 45 degree with the negative x-axis. This is the net force, but it is told how much additional forces should be applied so that the net acceleration of the body is 0. So it means the force that should be applied, that is this, which is equal to √2, and it should act at an angle of 45 degree with the positive x-axis. So √2 Newton should be applied at an angle of 45 degree with the x-axis. So option A is the correct answer. Then here it is told a 2 kg block is pushed against a vertical wall by applying a horizontal force of 50 Newton. The coefficient of static friction between the block and the wall is 0.5. So it means the frictional force is acting, and mu s, that is 0.5. A force F is also applied on the block vertically upward. The maximum value of F applied so that the block does not move upward will be. So it means it should just balance the static frictional force, Fs max. So F should be less than or equal to maximum static frictional force. So it means F should be less than or equal to mu s times n. Now here n, normal force is acting towards the left, so n will be equal to 50 Newton. So therefore F will be less than or equal to 0.5 into 50. That means F should be less than or equal to 25. But here actually F plus mg is also acting downwards. F plus mg, that should be less than or equal to the maximum static frictional force. Maximum static frictional force. This is wrong. This should be minus mg. Minus mg. So F should be less than or equal to Fs max, that is 25. So this is actually Fs max, maximum static friction. So this minus mg, m is 2 kg into 10. So it means F should be sorry, F minus mg, this will be, so F plus mg. Okay, so this means F should be less than or equal to 45 Newton. So option D is the correct answer. So the maximum value of F applied should be 45 Newton. A block of mass 40 kg slides over the surface when a mass of 4 kg is suspended through an inextensible massless string passing over frictionless pulley as shown below. The coefficient of kinetic friction between the surface and the block is 0.02. Coefficient of kinetic friction is 0.02. The acceleration of the block is given by the acceleration we have to find out. So 4 kg will go downwards. So this is the tension force of, so it will be G is 10. So 40 Newton is acting downwards. Here for 400 Newton is acting downwards. So normal reaction is also 400. So here it will be 40 minus T, that is equal to 4 into A. And here this is the tension force. So T minus mu K into N. Mu K into N, that is equal to 40 into A. So then if you add them, then we'll get 40 minus mu K into N. N is equal to 400 here. 400 Newton. So mu K into 400, that will be equal to 44 into A. Okay, so Now this will be 40 minus 0.02 into 400 equal to 44a. So therefore this will be 40 minus 2 by 100. So 2 for the 8 equal to 44a. Therefore a will be equal to 32 by 44. So 4 11s are 4 8s are 32. So a will be equal to 8 by 11 meter per second square. So the acceleration of the block will be 8 by 11 meter per second square. So option D is the correct answer. Here it is told that a block of mass m is placed inside a box, which descends vertically with acceleration a. The block exerts a force equal to 1/4 of its weight. The block exerts a force equal to 1/4 of its weight on the floor. The normal direction exerted on the floor is 1/4 of mg. Its weight is mg. So here it is told the normal reaction is 1/4 of mg. Then the acceleration a will be how much? So therefore we can say that mg minus n, that is equal to m into a. The net force downwards is mass into acceleration. So mg minus mg by 4, that is equal to ma. So m we can cancel out. So a will be equal to g minus g by 4, which is equal to 3g by 4. So 3g by 4 is the acceleration downwards. So option C is the correct answer. And here it is told a block of mass 2 kg, which is moving on a horizontal surface with a speed u, which is 4 meter per second. It enters a rough surface ranging from x equal to 0.5 meter to x equal to 1.5 meter. So here friction is acting. The kinetic friction is acting. The retarding force on in this range of rough surface. Okay, so here frictional force is not there. Here the retarding force is minus kx, where k equal to 12 Newton per meter. The speed of the block as it just crosses the rough surface will be how much? So this v will be how much, that is asked. So here we can say that force that is equal to minus kx. So therefore acceleration will be equal, or the retardation that is equal to f by m. Mass is 2 kg. So therefore acceleration that will be equal to f minus kx by 2, which is equal to acceleration will be minus 12x by 2, that is equal to, so acceleration is minus 6x meter per second square. And acceleration we can say it is the retardation, that is equal to v dv by dx. So therefore v dv by dx that is equal to minus 6x. So therefore v dv that is equal to minus 6x dx. Then we can integrate from 0 to v. No, not from 0 to v. U is 4. So 4 to v. And this will be from 0.5 to 1.5. Therefore, the integral is v dv from u to v equals to minus 6 into integral x dx from 0.5 to 1.5. So therefore this will be v square by 2 minus u square by 2, that is equal to minus 6 into x square by 2, which is from half to 3 by 2. Okay. So this will be, so 2 we can cancel out. We can take as common and we can cancel out. So this is v square will be equal to u square, which is 4 square minus 6 into x square. X square is 3 by 2 whole square minus 1 by 2 whole square. So therefore v square that will be equal to 4 for the 16 minus 6 into, there will be 9 by 4 minus 1 by 4, that is equal to 8 by 4, that is 2. So v square will be equal to 16 minus 6 into 8 by 4, that is 2. 6 to the 12. 16 minus 12, that is equal to 2. 16 minus 12, that is 4. So v square equal to 4. So v will be equal to 2 meter per second. So the velocity that it will gain, the speed of the block as it just crosses the rough surface will be 2 meter per second. So option C is the correct answer. So hope all of you have understood the solutions of all these questions based on the previous year JEE Mains exam on the chapter laws of motion. Still, any doubts if you have, please write that in the comments. We shall obviously clarify them in the subsequent videos. And mm, please install our Sapience education application also, where we shall upload some important homework questions based on the previous year JEE Mains exam, which shall be obviously helpful for your exam. So thank you everyone. Bye.